All right, so I thought we'd start maybe by, if you could do a quick intro of yourself and your company, like your 1-minute elevator pitch, so to put things in context so that people see you come from very different backgrounds and so they can set the stage for the conversation to come. So maybe we can start by you, Pierre, and then go forward.
So hi, I'm Pierre from Jenji. So we're an expense management solution. So it means you can invite a customer at lunch, for example, snap a picture of a receipt, and then we'll extract everything under 5 seconds using our own deep learning AI. So that means no vendor entry, no sellers, totals, VAT stuff, countries. And you can actually forget the paper because we're a paperless company, and you have full fiscal receipt storage for France and for a few select countries and more coming.
Hi, I'm Cédric, so I'm from Influans. Influans is a SaaS product that optimize your marketing campaign. So that means through machine learning, we'll be able to find the right product to the right people at the right price and to send an offer.
Hello, everybody. I'm Julien, Plée, CTO of Synthesio. Synthesio is a social listening platform. To make it short, we provide dashboards to our customer that shows mentions about their brands and their products.
Hi, good afternoon. I'm Loic from Tellmeplus. We are a software vendor specialized in predictive analytics and especially for industrial guys. And we try to enable field user and shop floor planners with a predictive analysis solutions.
All right, thank you all. So Cédric, I'm going to start with you. So, the title of this talk is You Have Data, Now Use AI, Machine Learning to Deliver Value. So is it as simple, like you plug AI, you have data, you plug AI, and then it's magic, you have value? Or
no, AI is not magic, unfortunately. If you have business issue, if your business doesn't work, it's not perhaps the only way to hire a data scientist and to say to him, okay, now I want more turnover. So the first stuff to do is let's say, to describe your problem, to describe your issue, to speak with your CTO, with your IT team, and they will see if they have data and if they can be able to optimize or to solve your issue. And they will also be able to give you an expected ROI you will be have thanks to AI project. But AI cannot solve all the issue, unfortunately.
That's too bad. I was really hoping for the silver bullet, but no. So Julien, how about you? Like, for you and your experience, where do you start with AI projects? How do you start?
My advice would be for you to ask you a question, and this question is, what value can I bring to my customer with data science and with AI? And I think that you need to define your business domain, your core domain that will expose data science, and maybe this is just your own core domain. But for example, for Synthesio, where we, as I said, where we track mentions about brands and products, we have 3 big domains of data science. The first one is NLP, natural language processing. So, for example, we try to detect sentiment on mentions of your brands and your products to know if your customers are happy or unhappy of your products, for example. We do image recognition. So, for example, try to detect which logo we have in an image. So, if your brand is in an image, and in which context your customers will use the product. And finally, the third domain that we do in data science is trends detection, trends and insight detection. So, as I said before, we show dashboards with flow of mentions on your brands, and what you will hardly do if you want to do it manually is to find sub insights inside the data that you can see on the different graphs that we show to you. So you can do manually the things, but you will need an army of people to make them, an army of analysts of data. And when we talk about thousands or millions of mentions, because an average dashboard for a customer is about 50 million mentions, you can't do it manually. And then you need data science to give you automatically what you could do with a lot of people.
For sure.
Totally agree. I mean, AI is a toolbox, and you have many techniques into that toolbox. Machine learning is one of them. You can use many techniques, but at the end of the day, what needs to be defined at the very precise moment, at the very beginning, is what is the value of everything behind that. So what value will I derive from this tool I might use to solve my problem? But basically the volume, the complexity has been a move forward, a shift from traditional statistics to machine learning system and automation. So probably AI is a way to automate things in that complexity landscape, but yeah, totally agree with you. Volume and complexity drives the necessity of a nice tool.
I remember when we were chatting the other day, you told me, you know, even though many of us are engineers, there's no point like building tech for tech. Like you even had a case where somebody asked you to predict something that didn't happen. Like, can you share a little bit about this?
Yeah, sure. Yeah, it was kind of a disillusion. I mean, we had a talk with this big company, French company, and we went through the talk several days, several weeks, and then at the end of the first phase, we just say, okay, guys, you don't have any failure in your system that we can work on. So probably you have failures, one, in a couple of years, and you don't need AI to solve that problem. Probably you need to stick to the problem first and not use a tool that is not designed for that, precisely.
The key thing with AI, we'll get back to it, is of course you need historical data, otherwise there's nothing.
You need historical data, you need a target, you need technical things that can be expressed into a business thing. Is simply put forward, okay, do you have failures? Yeah, okay, you need to predict failures, but do you have failures in history, basically?
How about you, Pierre? What's your take on this?
Well, I think there's also a way of you need to be able to cap the amount of work that you put in into AI as well, because obviously, as a SaaS vendor, for example, if so, we do two types of learning. One which is vision, which is like getting a receipt, extracting characters, and then building a model on where's like the VAT amount or what the what does it look like in terms of country, stuff like that. And we also do like more conventional, I would say, simplistic clustering type of learnings. So I would say the first thing is that you can actually build a lot of things with your engineering team. So they're more than happy to be able to build stuff for you if you ask them. So you really need to be able to cap, because once you start having a product, for example, that does, I don't know, VAT optimization in our case, then your client will actually ask more specific vertical requests. For example, if I take a very concrete example, so we do have pharmaceuticals company, for example. So if you take expenses, I don't know if you know, there's a law when you can't actually buy a dentist or something like big stuff. So he recommends your products. If your lab, your pharmaceutical lab, so you need to declare to the state these different things. So they come from expenses. It's a byproduct. So when you start doing that type of sort of detection, then people will start asking very specific vertical requests. And as a vendor, most of them don't make sense to bundle into a specific product, or even telling your sales team about it. So you need to be able to also concentrate on value and on your ability also to sell it, and that's a key point for me, I think.
That makes sense. So now let's move to the data topic, which we already talked about. You know, data is of course the cornerstone of AI. And there's different types of data. You know, there's structured data and structured data, broadly two main categories. And you know, you all had the experience with both of them. Be interesting to share a little bit of experience. Maybe Cédric can start by explaining us what is actually maybe the audience, what is structured, unstructured data. In your case, you know, structured data especially was very important, I think, in your company.
Yeah. I think there's a lot to do with structured data. So let me take an example just to explain this. At Influans, there is a customer that asks us to get their product picture and to do image recognition, to be able to do some category of product, to do some clustering of product, to group their product. So this is unstructured data. You have image, and you should try to find similarities between image and be able to group them. However, I think it's better to directly go to the CRM and take the category of the product and use that to do the clustering. So I think there is a lot of stuff you can do with structured data, and there is a lot of projects that use unstructured data where you don't need. So sometimes it's mandatory to use unstructured data. For example, at Synthesio, they explain they analyze an image to find the logo. The data is nowhere in structured data. So
yes, but that's the same thing as you. We did in the beginning to train our algorithm in image recognition. We based it on the hashtags that we found the image on Twitter.
So structured data.
Yes, so that was structured data, the same as you.
So maybe Julien, you can tell us a bit more about this experience you had. So you say, so unstructured data, for example, that could be text, that could be images. But in your case, I think you did some sentiment analysis on that unstructured data. And I know you had a journey through different approaches. If you could share a little bit what your journey was.
Yes, of course. We for the sentiment analysis, we came from doing it very simply and more complex over time. So we had 3 major evolutions of our algorithm. The first step was to make it rule-based. So you had dictionaries of words that were connotated for happiness, for example, and other words that would say that you are unhappy. And when we find these words, we would tag your mention or your document as positive or negative. The second part was the second step was with machine learning. So we used algorithms such as NLTK, LongID, different Python libraries. And now we are doing deep learning on this kind of sentimental analysis with recurrent neural networks. And that obviously gives better results. But that allows us to make it more complex over time and to deliver value very quickly to the customer. Because we weren't equipped to make deep neural networks from the beginning. We haven't the people expert in this domain. And it allows also us to take time to build our training and evaluations data sets. Because when we did it rule-based, we didn't need to create data sets for training an algorithm, for example. Just my feedback on this is that I think with the perspective from now, it's good to see that it's a good way to make it simple from the beginning, to start small and to increment the complexity of your algorithms. Because data preparation that you need for more complex algorithm is really a big amount of time that you need on your project. And I continue, I don't know. On this subject, about data preparation, we had a lot of time needed to prepare the sets, and we saw that we could spare time by industrializing this preparation. So now, for example, we get the real data from our production data as a set that is automatically created to create the training and the evaluation set, sorry. And we will talk, I think maybe later I will do all the speech otherwise. But so we face new problems now that we have industrialized the preparation of the data. But this is a big impediment in the beginning of your project. So that's why I advise to begin simply.
It was interesting for me what you said about you had this journey, and deep learning requires special skills. People who know deep learning, obviously, but it's not only that. Even if you had, people with deep learning skills at the beginning, maybe you would still have had to go through a journey because you learn things along the way.
Yes, you're right.
So talked about data preparation. Of course, it touches on the topic of data quality, which is key. And I'm sure several of you would have stories to tell about this. It'd be interesting to share with the audience, Pierre or Cédric or Loic, if you have.
Yeah, I mean, in the industrial background and landscape, we play with massively structured data, but sometimes we are mostly playing with structured mess, actually. And if you think about, census data, I mean, there are time series organized data. Single point in time, you get the data from any sensors. And unfortunately, they don't come at the same time. There's no isochronicity. So preparing data, and we know machine learning and AI is not very, very suitable for analyzing those kinds of data. So basically what we need to do before is preparing the data the way you do it. We industrialize lots of things around time series data to keep the mess out and getting things structured for the sake of algorithm we use. But the time algorithm will be able to structure that data is not yet to come, I guess. There is a long way to go before we will achieve that. So we need some kind of structure in the project where you basically identify precisely what work will need to be conducted on that data before you run for the first analysis. It's a very iterative process. So the quality of data and the total mess you will face there is very time consuming.
Yeah, I think there is a famous expression, garbage in, garbage out. So what you should do, if you can, is let's say to do a data quality firewall on your data prep. So meaning you will clean the data before put the data inside your cluster, inside your data lake, etc. Because after, the bad quality is like a virus. It will go everywhere and it will be very complex to clean. So sometimes you cannot because you need the power of the cluster to do the data quality. For example, if you want, I don't know, do matching, fuzzy matching, you need to have the data that are in the cluster, and you want to use the cluster itself to be able to do this and to use machine learning, for example, to do this cleaning because it's highly CPU intensive, so you need the cluster. But when you can, before having the data inside your cluster, clean it.
There's also a case which is interesting, and for example, a case with expenses. So that means when you extract something that is missing, for example, if you don't have a specific VAT structure for Brazil or something like that, and then you let the user actually enter it. So if you do have the chance to have a feedback loop, whatever that is, that's also a good way, to on the cheap get access to sort of supervised. So it's always interesting when you have a case where you do have user feedback on your results, and that's big plus. It's not all our cases, for example, but for these ones you can still train and train and train again. That's definitely a plus.
Yeah, keep the human in the loop. Yeah, that's mandatory. Nothing is automatic. So keep the human at the very heart of the loop.
Yeah, especially at the beginning, providing the baseline for all these algorithms and the training, obviously. So we talk about feature, all this preparation, data preparation. It's a lot of work. But there's some new methods, like this concept of auto machine learning that is starting to become more popular. And I think some of you have experience with it. Maybe Cédric, you wanted to talk about this a bit?
Yes, we implemented automatic machine learning. So meaning we'll be able to automatically, so meaning it's a computer that will do that, not a human, automatically do feature engineering. So meaning on your data, be able to take the good data that you will feed the mathematic model. So this step is usually done by data scientists trying a different way to put the data inside the model and see what is the quality of the model, and trying again. So this step can be do by a computer automatically. Another step we do some automation is to set up the settings of the model, what we call a hyperparameter. So there is also some technique to be able to update the setup, to try the model, to see it's better, it's not better, to update again the parameters again and again. And it's something also that is done usually by data scientists. So in fact, what you do with automatic machine learning is to be able to set automatically your model without the need of an army of data scientists, because more and more you will have data from your customer, from different customers. You will need to optimize, let's say, to set up all these models.
Awesome. So let's move on. So we talked about kind of you need to have a plan, you need to have a business plan, a business outcome in mind to start. We talked about the data, a lot of work there, obviously. So now let's assume my data is relatively clean. So where do I start? Like, what do I have to keep in mind as I'm starting on this predictive journey? Pierre, maybe if you want to get started on that one.
Well, I think for us, there's really a rift between what is actually science and what's actual implementation. In that, I mean, for example, so we do both vision and like more classic clustering things, or fraud detection, for example. So fraud detection, it's actually a field like building single points, stuff like that, which is actually very well written about. It's pretty easy, and you don't really have anything to invent. You can use any open source toolkit, and that will probably do the job very well, provided your data is okay. Whereas on the other end, like something like vision is a science thing. It's still difficult. You need to be able to build your own algorithms, try them. Most of them will have extremely difficult debugging to do. So that's definitely something you need to factor in. And I think that's a very big difference from something that you can actually forecast. Like say, I want to build a fraud detection system in a week, like a very POC thing. And then something where you say, I want to, do 2% more accuracy on something, which can actually take a year, or can actually take 2 days.
Or may never happen.
Yeah, or may never happen. So I think you need to be able to quickly dispatch between things that are doable by a dev team, provided they have, even outside help, like someone which does the model and they serve it, and you can work with it. Or things where you can actually need to have scientists or people that actually work on it, and you never know. So,
Cédric, did you want to?
Yeah. So how to start? I think the first stuff is to understand your data. So because if you have no data or not the good data to solve the good problem, it will not happen. So I think first step is understand the data. And one takeaway important to I think to mention here, it's don't ask your IT team to use deep learning because it's fancy, because I read that on a newspaper. So I want for that you use deep learning to increase my my conversion rate. It's not the good way. You just need to explain precisely the problem you want to solve, the KPI you want increase. And your data team will be able to choose the right algorithm. And perhaps it will not be machine learning. I'm sorry, it will be a rule-based. It will be something else. But don't think deep learning will, for example, solve all the stuff. Or random forest is a great algorithm. Please put random forest to do that.
It does have a cool name, though. I always wonder what a random forest looks like in reality. It actually exists. It's not a joke. Sometimes people think it's a joke, but random forest is a thing in machine learning. Julien, did you want to continue on this topic?
But just before, I would like to come back to what you said about automatic machine learning. to share a similar feedback, because it's really interesting that you build this feature. What you need to know if you don't know data science projects, that's when you put your algorithm, your model in production, is 5 minutes later is becoming false, because the data you use to train it, they are not the same as the data that you will have in production a long time, and so you need to regularly take a new extract of the real life data, and to assess your model against them, to know if you need to retrain the model. So what you did is automation of this problem that costs very, very much time to the data science teams. And about how to begin, I have maybe more an organizational standpoint to give. The data science team in Synthesio, the first guys that we hired, they were most the kind of research data scientists, and the people that we recruit now are more the applied version. We can tell the applied version of the data scientist. And what I mean is that the first one were people with PhD in data science. They write papers about data science. They make algorithm evolve. So the algorithms that you can use in Python, some of them have been evolved by Synthesio people. But we face a problem when it was time to go into production. The model were perfectly working on their laptops, but they won't never work in a production system. They were not scalable. They were not able to handle lots of data. So we hire new kind of data scientists, what I call the applied version, data scientists that know perfectly the algorithm, but that will just pick and choose a good one and use it to the problem we face to handle it. And they are well interfaced, sorry for the technical term, with data engineers, or backend engineers, the guys that handle data stores on a daily basis. So my feedback on it is that think about the kind of data scientists that you want to find, because on the market there was a lot of different kind of people under the data scientist name, and not every company want to evolve algorithm. Some companies just want to, like we do now, select an algorithm and make it into production. And this is a special competency to be able to discuss with data engineering people.
Yes, but just to add something on that, at Influans we have in fact data scientists that are more mathematics guys, that are very good to find the right model, but that are not good to code, not good to do error management, and you need error management on production, not good to scale an algorithm. So usually there is the data scientist do the model, and after work with the data engineer that will implement it, recode it from scratch to be able to have a version that go in production. And what we put in production, for example, it's on different technologies that what the data scientist will use. He will perhaps use Python to do his algorithm, and the data engineer will use Spark Scala, for example, another technology, to put it on production with all the tools we need to monitor, to manage, and to scale it.
Yeah. So Loic, you're in a slightly different domain, you know, industry and all that. So can you tell us about in your world what it means to run all this? And
for most of our customers, I would say the main point using AI, using machine learning, is trying to solve something that they already know the outcome, the output. Basically, they have explicit knowledge. They've built their businesses on complex things, complex processes, complex knowledge. And what they want to be able to achieve at the very end of a POC, the POV, whatever you call it, is at least at the very first hand, trying to retrieve this information, this knowledge into the model we've built. Because they get the reassurance that this technology can give some answers that they can understand. First of all, because they will need to act on the prediction. If you say, okay, you're going to have a failure, you're going to have a bad quality for that product into that process, they need to act on it. If you don't understand your model, your output, they will not be able to act on it. So the very first thing they need to do is get the confidence that the technology can give them some answers they are able to understand. It's explainable AI. I don't like the word explainable. At least it's interpretable AI. At least. They can read the thing and say, oh, okay, that I know. That's the truth.
So a question I often get from entrepreneurs or bigger companies is on the ML journey is, you know, the build versus buy. You know, like, should I invest a lot of money and effort and resources in building my own system and own it, or should I, you know, leverage the massive ecosystem that now exists? So I'd be curious to hear, you know, your thoughts, you know, on this topic.
I would say the problem we are solving are so complex that the buy it is becoming in 2018 the first gap, the first reflex they get. They say, okay, we will not solve that by ourselves. We will need help. Would it be a service company that would help us with data scientists, lots of, you know, brains and whatever, or something that could accelerate the thing? What we need and what we see today on the market is fail fast, learn fast. The fastest you fail, the fastest you've learned something. If you spend 9 months trying something and you fail at the very end, it's a catastrophe, it's a disaster. If you spend 9 days and you say, okay, this is not the way we should do it, okay, that's a chance you give to you to move forward.
How about you, Pierre, Cédric, Julien, like on the buy versus build? Like, you know, some of you have tried things internally and went with partners, for example. Like, what are some of the advices you may share with the audience on that topic?
So we don't buy anything, so I'm not really probably the best one to answer. But I think there's a different point of view, is that when you actually build, it's like part of your IP. So as a startup, that also means your own sense of freedom of what you can do with the technology as well, and also your perceived value is actually a lot higher. So it's interesting to see that deep learning, in a way, it's an interesting technology as well, because it's a very complicated technology for most people. So that also means there's a step to cross if you want to have a model that actually works. Because at the end, there's a user that says, as you said, explainable or not. And if it's not explainable, even if it's like some part of it is true, maybe we'll actually perceive it as something that has no value at all. So I think it's pretty complicated, and that also does bring a lot of value to a field. Obviously, what I said about science project is that there's a lot of things that are really out of reach. Like, I don't know, even like maybe doing an autopilot for a car. You know, you need to be probably very specialized to do something like that. And it needs to be like a mission to build something like that. So, you know, maybe even would make sense to buy if you're like a Renault or something like that, because you're not an expert on that. But, you know, for most startups, most of the things on AI is probably your core business. So it makes sense to build it.
So I think we have just a few minutes left before opening up to questions, so you can start thinking about your questions for the panel. But maybe as a closing thoughts, like we saw AI as a journey, it's complicated, it takes time. So maybe some last advices on how do you then kind of progress on this journey? Like how do you evaluate it? How do you move forward? What are some of the key milestones? And be curious if each of you could give a few, we don't have much time, but a few sentences on that.
I think first takeaway I want to highlight is feasibility. So you are not a R&D lab. You are a startup, you are a corporation, you are a company, and what is very important is not to try to have the better quality on a machine learning model. What is important is to be able to build a machine learning model that can but that can be able to be in production. If not, you can spend years and on perhaps years and years before going in production. So sometimes it's not the best model you will put in production, but it's the model that can run, because some model will take too much time or too much CPU, and you should save the planet. But it's not important. It's the model that will win is the model that can be in production quickly.
Yes, I would say the same thing. Think about production from the beginning, because this is where you will spend most of your time. So think about scalability, think about the way you will get new data to reevaluate your algorithm and to retrain them. Because if you don't think about it when you draw your system, when you design your data science model, you will just look at the emerge part of the iceberg, and in fact under the sea there is the most of the work that you will forget.
No, totally agree. I mean, algorithms are becoming commodities, and what you need to stick to and very focused on is being able to industrialize things, put things into production. So start simple, put things into production from the very beginning, and try to give your pipeline some kind of coherence, because we see sometimes things that are totally fuzzy. So try to do things very linear, very pipelined, I would say, and start simple.